mitigation to try to stop future attacks. The hackers are always looking for new ways, and they're always trying new ways in. And so even if you do all the right things, sometimes things can still go badly. Plus, there's a lot of other things that can cause business continuity problems. It could be active violence, active terrorism, disgruntled employee. You can have a weather event or an energy release. So we know, like here in New Jersey, when Hurricane Sandy hit, most of us were out of power at least a few days, and many people were out of power for several weeks, and that had a big impact on businesses that you had no power. It was kind of hard to stay operating. And now, of course, in the last year and a half with the pandemic, there's been disruptions caused by the need to quarantine, either because of individuals in the facility you're concerned about spreading the virus, or in some cases, if a facility has become contaminated and people are not able to go in to work. So there's a number of things that can cause problems, and then there are even the mundane things of equipment just failing, whether they're failing because they were poorly designed, or if there's power surge, something that does damage, or just due to age. So it's critical whenever any of these things happen, that all these can impact your business, and if you don't have a plan in advance, then you don't know what to do, and then you're going to suffer the greatest consequences. The risks run from the catastrophic to the mundane. They really do. So it's really across many avenues, because the focus when we first started was on the big ones, major events or cyber security issue, but really anything, like I said, down to maintenance issue, like we've got this old part and we don't have a backup. And one thing to also understand too, particularly like with when I mentioned like trying to bring documentation up to date and making sure you have backups, all systems will eventually need to be replaced and upgraded. As long as your facility continues to operate, at some point you're going to have to replace legacy systems. The more complete your package of documentation and backups is, the fewer questions that anybody bidding on the job will have. And if you can hand people, all the potential bidders a package that said, here's the design documents, here's the drawings, they're all up to date, here's the user manual, the current user manual, here is the backups of all the PLC and HMI applications, database applications, reports. I want to replace this functionality as it stands today with maybe whatever modifications you want. You hand that to integrators, and those bids will come out so much more tight.
Everything that we're discussing here, the infrastructure we're discussing here, it doesn't just apply to actually a ransomware attack or a hacker attack. Any of the components here are important to focus on, because if they go down for any reason, be it natural disaster or lack of proper maintenance of equipment, if they go down, that would be a critical break in stopping of your ability to do production. And also, I like to say with this attack, like people like to focus on the actual the malware that was used, but I think it's more interesting to focus on the steps prior to the development of the malware, because there's a whole portion of prevention that gets into business continuity there, where it's on the human element, on the human side, where analysis wasn't done in advance so that they know how to prevent this kind of disaster to happen. So yeah, this is the second attack. Now this is the second of the slides. It focuses actually on the ICS portion where they did the attack, and now I'm going to want to go to the next slide because, okay, so this is the key component here we're talking about. Now what they focused on in this attack was they focused on controllers, firmware controllers, to take down controllers. They also focused on the serial to Ethernet communication devices. So they focused on taking those down as well to break communications. And the idea with this slide is we're just saying that there are specific components in your industrial control system that pretty much at any of them you will recognize as having in your system, and you have to be aware that these are just any type of device like this, you have to be aware of what can happen if they go down, or if something happens to them, and how they can break your ability to continue to do production. So the serial, the Ethernet communicators, they went after the UPS systems. So as part of this, when they did the power outage, they made sure that they took out the UPSs, so the UPSs weren't able to provide power so they could run. They also went after an internal communication servers. They went after a couple of different types of servers, but one specifically internal communications, because that way they weren't able to communicate on the plant level. And as another aspect of this, they went after the local call center. That wasn't connected to the plant, but the plant itself relied on that call center for customers and clients to call in to get information on what was going on. So they took that down as well. So it shows, like, not just inside your facility you have to be aware of what your infrastructure is and what it's doing, but also infrastructure in the area that you rely on in order to perform to do what you do as a business. And the final, possibly it might have been the most important part of the attack, was they went after Siemens relays. Now they had an attack on those relays where the idea was, for the initial part of the attack, they opened them so that they can break power, so that they could lose power for the facility. But the part that didn't go off, luckily, was when they brought the system back up online, they were supposed to they had malware that was supposed to keep it so that the relays, they wouldn't open. So if there was a surge or something, some kind of surge, they wouldn't do what they're supposed to do, and that would actually destroy the actual equipment and infrastructure, which would have led to more than the 3-hour outage they had. They could have been out for months at that point, because anybody who deals with this type of infrastructure knows what happens if you actually have a piece of equipment that burns out, a motor or something, and then you have to do the replacement of that. So those right there are just like 5 pieces of equipment you have in your infrastructure that you need to be aware of, and makes you aware that there are others you have to be aware of. You have to know what's going on with these. So if some kind of disaster does it, be it a ransomware attack, be it a natural disaster, be it power outage from the local area, you have to be ready to take on, and have a plan in place for dealing with that.
And so we're talking a lot about business continuity locally, but then there's also a component of third-party risk. And so when we get into enterprise business continuity planning, it's amazing all the different stories that come out of people that talk about, we planned for this, we planned for that, we never planned for this other thing, and that's what took us down, right? You're always prepared for the last thing that happened and not prepared for the next thing that happens. And so what we do at Decision Point in working with ICA is we can go into an area, and what we'll do is perform a business impact analysis, help you understand your cost of downtime if you don't know it, and then get into all hazards planning. This is also something you can do yourself. And what is all hazards planning? So 20 years ago, you had a fire suppression plan, you had a flood plan, you had an earthquake plan, that sort of thing. If you can go to the next slide. Actually, go to the next slide after this, please. What actually all hazards planning is about understanding all of the pieces that interconnect and understanding what would happen if one of those pieces became unavailable for whatever reason. This is a really, really busy slide, but what it shows is how the employee connects all the way back to the backup job, and how, when you understand how these things are connected, it can actually come right back to how much money are you going to lose if that becomes unavailable for whatever reason. And then it actually switches how people think, and they start to understand, oh, this component here, while we never worry about it because it's never failed, we didn't realize over time maybe we put all of our business process through it, and now it's very, very critical. And that's why a business impact analysis is very important. But also along with that, it's having a full suite of plans. If you can go back one slide, please. So this is a full suite of plans that we develop for the larger companies, Fortune 500s, that can put a full staff behind it. Any size company can benefit from any of these plans in a smaller size. In each graphic you see there, each box that you see there represents a different kind of plan. Some of it is multi-departmental. So in the sandworm attack, hey, we've lost power to the entire building, or maybe our whole campus of buildings. That's going to be something that affects all of your departments, and you'll have to bring everybody together to figure out how to get around that. Or it could be something that just affects shipping. As Joe had mentioned before, you could have some sort of pandemic, influenza, or like we've been seeing with COVID, it could shut down a whole department. What would happen if your shipping department suddenly became unavailable, the people were suddenly unavailable, or even receiving, if you're bringing in those raw materials that you're then turning into whatever your products are. And then lastly, one of the things that we help people do too is go to the next slide, please. Oh, actually you're there. Sorry. One more, there we go, is how to exercise those plans. So once you think you've got a good understanding of it, actually going through and exercising and really understanding, this is a generic data center recovery exercise that lasts 72 hours. And every exercise is a little bit different, but really working on those assumptions. What would happen if you told all your staff, don't come to work tomorrow, but write down everything you would need to have at home? Now, we've already figured that all out because of COVID, but understanding what your assumptions are is really important. I was at a large Blue Cross facility, and they didn't put any stock into having a lockout plan. What do we do if we have to evacuate the building? Well, about 6 months after the executives decided they wouldn't need that, the family courthouse that was right next door suddenly had a bomb threat. And the sheriffs came in and said, everybody has to evacuate the building. There wasn't anything that happened in our building, and it wasn't anything that we did. It was a third party, it was something outside, it was an environmental risk, and suddenly all business stopped. What are you going to do in that situation? The assumption was we would never have to close the building. But when you're talking about manufacturing, you're talking about those controls, understanding your environment and knowing what is in that is such a critical thing.
Our customers and ICA's customers have a lot of automation assets out at your site, locally and perhaps even at remote sites or stations. And these are all of your automation devices like controllers, HMIs, drives, managed switches. And each of those has one or multiple configuration files or programs that are associated with it. And so organizing and managing all of that content alone can not only be daunting, but it can even be risky for your operations and your business continuity. So an asset management solution, like say FactoryTalk Asset Center, centralizes the management of all of those assets. And it ultimately saves you time and it saves you money through reduced downtime, more efficient use of your personnel, and improving your security and your safety. Next slide, please. Some of the common challenges and the risks that our customers like you often face include lost configurations and device failures. So for instance, if one of your PLCs were to fail right now, do you know precisely where to go find the code? What about a managed switch configuration file? I've seen customers down literally for days because of those types of issues. Maybe you have multiple versions of documents that you have to manage. Additionally, as your production environments change, as pretty much all of them do over time, you have to think about how you're managing and documenting that change. Do you know who is making the code changes? Do you know why they're making code changes? Unauthorized and undocumented access is a concern at any manufacturing site. So having that ability to restrict access to certain parts of your process are essential to production and safety. And the primary goal of FactoryTalk Asset Center is to reduce or to eliminate some of those concerns. And working with a partner like ICA Engineering that's familiar with your process, your assets, and the solutions is really essential to an effective implementation. Next slide, please. So very briefly, I just want to highlight some of Asset Center's capabilities. These are the core capabilities of Asset Center, broken into 5 categories. And first, you've got the archive and disaster recovery piece. That archive enables you to centrally manage all of the versions of your programs, your files, and your folders, and it gives you source control, meaning that people have to check in and check out those documents for editing, which ultimately ensures there's a single version of the truth. Asset Center can also back up the files living on your automation assets. Next, the auditing capabilities of Asset Center allow you to track all of those detailed user actions in real time. So if there was a code change that was made, you're going to know who was logged in, where, when, and exactly what code changes were made simply by reviewing an audit log. Another core feature is security. So Asset Center gives you total control over your automation system. You determine who can view or edit any electronic document. Perhaps you only want your maintenance employees or your controls engineers editing your Studio 5000 programs, okay? You can also manage asset life cycles with Asset Center. There's an enormous install base of legacy equipment out there. So if there is a migration path, Asset Center is going to tell you what that path is. And finally, it supports third-party devices as well, not just Rockwell. So in conclusion, I would encourage you to have a discussion with ICA Engineering about how you could implement some of the tools we talked about today to bolster your security, to more efficiently manage your assets, and to ultimately ensure your business continuity.
So we've developed something that we call the system lifecycle evaluation. This is particularly important for people who do have legacy systems. And so one of the things we do is we come in and we catalog everything we have, because like we said before, if an asset goes down for whatever reason, you need to know what you have. You need to know make, model, firmware edition, and all that, because all that can impact how things get repaired or replaced. Can the thing be repaired? Can it be replaced? If so, what's the migration path? If it can't be replaced directly, if the existing model doesn't exist, and these can all affect the configuration. One of the things that Troy mentioned is about version control, and this becomes very important because it's one thing if you have ICA as your controller, as your integrator, and we're making backups and we're keeping them on our site. So chances are, if something goes wrong, we've got a backup. But there can still be, if you have other people, if you have multiple companies coming in, version control becomes critical, because we come out there and we do some work, we got a backup. Somebody else comes in and does work, and maybe they make some changes. If we don't have that backup and your system goes down, and we come on site and we install the backup we have, because you didn't get a backup from the other guy, now what? Now all of a sudden you've got an old copy that may have errors that the other, that have to be resolved, or maybe there were system changes that are not reflected in the old code. So this is critical. So part of our approach. So there's several pieces. So the first is inventory. So we go through, we catalog everything that you have, every automation asset, every controller, every switch, every drive, all of it, anything that's connected to your control system. And then that also includes documentation, because in a lot of cases we go out to customers that have had older systems, and the system is either not well documented or the documentation is very well out of date. There's been a lot of changes that haven't been reflected on drawings. The design document is no longer representative of how the system works, or there isn't one at all. There's either the user manual doesn't exist, or is again hopelessly out of date, and this becomes a training issue as well. So we also catalog documentation. The next we do is a gap analysis. Say, okay, what are you missing? In some cases, when it comes to backups, there are some legacy systems where it's not possible to back up from the controller or from the HMI, that you have to have that original development file. And if that can't be located or obtained, that's a risk. So this is something that becomes a big problem potentially in the future. If system does get knocked out or taken out, whether it's temporarily or permanently, this becomes very difficult to try to deal with. Then once we have that, then we can go through a risk analysis, and then we start going through all these scenarios that everyone's talked about: weather events, energy release, force majeure, active violence, quarantine, whatever it is, whatever could have caused it, or just old part that burned out, and try to come up with an expected time to recovery. How long is it going to take you, based on these various scenarios, to be able to get your operation going again? And pointing out, where, so then you can identify what are the greatest risks, what are the least risks. The final part is a remediation plan. Is to say, okay, based on what we have now and based on the risks, where are our priorities, and what are budgetary numbers for trying to mitigate all these risks. Is that in case of legacy parts, a legacy system where the parts are still available? Maybe the idea is, well, we're not going to be able to afford to replace the system in the next 5 years, but we can get spare parts today and put them on the shelf so that if something goes wrong, we can at least recover fairly quickly. In the case of HMIs, where there's or PCs that have like control software on them, whether they're your HMI software, your programming software, or all the above. We can do not only do we back up individual applications, but do image backups of drives, because we just had a client recently. They got an old system that we rebuilt once, and we offered it's a server, so the backup software is a little more pricey. They didn't want to spend it, and the system went down again, and we had to rebuild the system again. And if we had an image backup, that would have been a few hours worth of time to re-image the drive and put everything back in operation. As it turned out, because it's an old system with a very old operating system, it took multiple days to get everything in, try to get all the updates installed, which was difficult, and then get all the software reinstalled and retest it. So these are the types of things we try to do to try to minimize your risks. And now that we're working with Decision Point, we can offer now extending beyond just the industrial control system arena. So, and it's particularly important, like I said, with legacy systems, because the availability to get support from the manufacturer dwindles over time, and so does the knowledge of the knowledge base. Because once a product becomes obsolete, the number of people around who know how to service it drops off over time. So the better you have things cataloged, and the better you have things backed up and spare parts or whatever else is necessary, the quicker you can turn around.